Now let us start the next point. Microstates and macrostate of a system. To explain these two terms for a given system, we use the concept of phase space. That concept we discussed earlier, and it is a 6-dimensional region where every molecule, its state is specified by 6 coordinates related to position and momentum. Such in that phase space, we choose a gas system or a gas assembly. That gas system, which consists of very large number of molecules. Each molecule in that system we considered as a phase point for a given region. Now that means the phase point which gives the state of motion of each molecule. Now we are considering this number of phase points. Those are lies in a particular cell of a phase space. That cell is a small region whose volume is dx, dy, dz, dpx, dpy, dpz. In that cell, the number of phase points are lying in that region. Now using that concept, we have to first define what is microstate of a system. Now that microstate of a system we define here. It is defined as the specification of the place of each phase point. That phase point we call molecule within the dimension of, within the limit of dimension of cell. That means every microstate represented by the actual position of a phase point within the limit of dimension of cell. Now, what is that microstate? It means if we specify a phase space, means it is divided into number of cells. That cells we call cell first, we call cell 1, cell 2, cell 3 and so on. 1, 2, 3, and in that one we have to place each phase point. That each phase point is identified as A, B, C, D, E, F, and so on. These are the number of phase points. That phase points are placed in particular cell. If we suppose the first cell, it specifies only 2 molecules or the phase points A, B. Next one is E, F, G. Other cell we call C, D, G. Sorry, C, D, H. Now these are the number of microstate. Means the cell 1, within the cell 1, within that dimension of the cell whose volume is dx, dy, dz, dpx, dpy, dpz, within that cell the 2 phase points which are placed, which is within that limit. Similarly, cell 2, it specifies 3 molecules or the phase points E, F, G. Similarly, third one C, D, H, and so on. Now these are the number of cells. Such a specification of the place of each phase point in particular cell within the dimension of that cell is called as microstate. Now then we define the another term. Now what is macrostate? The macrostate of the system is also defined as, it is defined as the specification of number of phase points in each cell of phase space. Now see, in that earlier example, cell 1, it contains 2 phase points. It is one of the macrostate. Cell 2, it specifies 3 phase points. It also gives the another macrostate. Cell 3, it also specifies 3 phase points. Only we considering the number of the phase points in that cell. Here are again 3 phase points, and it is again another macrostate. Here, if we interchange the 2 molecules in the 2 different cells, now what is the condition we get? By interchanging two phase points in 2 different cells, then what is the result? We get different microstates. Why we get different microstates? Since the place of the 2 phase points gets changed in another cell. For example, if A is replaced in second cell and E is replaced from second to first cell, then we get different microstate but same macrostate. Why macrostate is same? Since macrostate which define only by specifying the number of phase points, and therefore we get same macrostate, same macrostate. Second point we see here, by interchanging two phase points in same cell, then what happen? We get same macrostate and same macrostate. Since number doesn't change, also the phase points interchange only within that cell, therefore the microstate also remains same. In that way, if for same macrostate, we get different possible macrostates by interchanging the different points in different cells. Now we considering the another example. In that example, we say tossing of coins. Now what is that case? If we toss the 3 coins of rupees 1, 2 rupees coin and 5 rupees coin, then we count. Now what are the possible outcomes of getting head and tail? If coins are tossed, whether we get head or tail. Now these possible outcomes we count for the 3 coins and we measure corresponding macrostate of getting heads. That macrostate related to number, hence we write n for getting heads, and what are the possible microstate corresponding to that macrostate. Now the first outcome may be 3 coins getting head, head, head. Then what is macrostate for getting head? That number is 3 and possible microstate is only 1. Second possible outcome, we write the first coin get tail, other 2 getting head, or head, head, tail, or you write head, tail, head. Now which is the macrostate corresponding to getting number of heads? That are 2. 2 heads getting, but for that macrostate it corresponds how many microstates? 3 microstates. Now the another outcome may be tail, tail, head, head, tail, tail, or tail, head, tail. Here the macrostate for getting corresponding head, that is 1, but that macrostate getting how many possible microstate? Again 3. The last outcome is all getting tail. Macrostate is 0, no any head is getting here, therefore it is 0, but possible microstate is 1. Now what it shows here, the macrostate corresponding to with 0, 3 of getting head have only one possible microstate, and macrostate with 1 or 2 for getting head we get 3 possible macrostate. Now this is one of the example to distinguish between the 2 points, the micro and macrostate. Hence remember, microstates which specify the place of each and every phase points within the limit of dimension of cell, and macrostate which specify the number of phase points within each cell of a phase space. Now these 2 examples explain what is micro and macro state. Now then we explain the another point, that is accessible microstate. Now what are the accessible microstates? That we firstly define. The microstates which are allowed under given restriction, that microstates we call accessible microstates. Now we explain that point by taking the example. If we considering 3 phase points, or we say molecules which are distributed in a box of 2 equal parts, then how many microstates we are getting under the given restriction? Here the restriction is that no any phase points can remain outside the box. Now suppose the box is divided into 2 equal parts, 1 and 2, and within the 2 parts the 3 phase points are distributed. Which are the phase points? Like A, B, C. Now these are the 3 phase points. Here in the first half the 2 phase points may be present here. C means a box which contain the 3 phase points, no any phase point is outside the box, and therefore it represents one of the accessible microstate. Now another macrostate is that A, B, C. Next one, B, AC, and so on, or we interchange the number of phase points in the two equal part, the microstate remains same. Also, this is one of the macrostate, 3 points distributed in two equal parts of a box. This is one of the macrostate. That macrostate corresponds to different microstates under given restriction that no any phase point is outside the box. Therefore, these are the number of accessible microstates. But in the case if one of the phase points is outside the box, like C is outside the box, here B is outside the box, here we write A is outside the box. These are not considered as a accessible microstates. Hence, accessible microstates, which gives only under restriction all phase points should remain inside a given box. No one is outside that box. The resulting microstate acts as an accessible microstates. Now, in the today's lecture, we explain in detail about what is micro and macrostate. We once repeat again. Microstate is specified by placing each phase points within the limit of dimension of cell, and the macrostate is defined by specifying the number of phase points in each cell of phase space. If we interchange the two phase points in the different cell, we get different microstate for the same macrostate. Again, we interchange the two phase points in the same cell, then micro and macrostate remain same, but hence we say that for the same macrostate we get different possible microstates. Thank you.